This is my math assignment for term 2. So the first question we have is determine whether the following series is arithmetic or geometric, and you have to determine the type of series and the sum of each series. So we have the sequence 5 plus 9 plus 13 plus whatever numbers, and then the final term is 213. So right away we can tell that it's an arithmetic sequence because it goes up by a constant amount. Because 9 minus 5 is 4, and 13 minus 9 is 4. So it goes up by 4 each time. So we can determine that A, which is the first term, is 5, and D, which is the common ratio, so 9 minus 5, which is equal to 4. So D is 4. So the equation to find the amount of terms for an arithmetic series is T of n equals A plus n minus 1 D. So we simply have to plug in A, 5, and D, 4. And then we get T of n equals 4n plus 1. So we know that the final term in this sequence is 213. So we add 213 right here, and then we make it equal to 4n plus 1, because we know that the last term, T of n, is 213. So then you solve this, and eventually you get the number of terms in the sequence is 53. So this is the equation for figuring out the sum of the entire series. So n, which is the number, like the term number, t1, which is term 1, so that's always the a value, which is 5, and tn, which is the final term, 213, and finally it's all divided by 2. So after solving this, we get that the sum of the entire series is 5,777. And it has 53 terms, and it is an arithmetic sequence because it is constant. The difference between each term is constant, and that is very easily visible in the first 3 terms, because it each goes up by 4 each time. So the second question is on page 161, and it's number 13, and the question is, if the terms 27, x, y, and 8 form a geometric. Right away, we know that the a value, which is the first term, is 27. But the r value, we don't know what it is. And the final value, so t of n, is 8. Because 8 is the final number. So in a geometric sequence, because it states it in the question, the equation to find out the amount of terms is t of n equals ar n minus 1. But right now, we don't know what r is, so we have to solve for it. So t of term 1, which we know is 27, is equal to 27r 1 minus 1. Because n, right here, n is the term number, which is 1. So we don't even need to know the r value to solve this, because anything to the power of 0, so it would be 27r to the power of 0, is always 1. So it's just 27 times 1, which equals to 27. So term 1, as we already know, is 27. So for term 2, which is the unknown x, we do t2, which is term 2, is equal to the a value, 27, and the r value, which we don't know. And it's 2 minus 1, because it's term 2. So for t of 3, it is equal to term 3, 27r 3 minus 1, because it's term 3. And finally, for t4, it's 27r 4 minus 1. But we already know t4 because it gives it to us. So t4, term 4, is 8. So we can plug this in. So you plug in 8 for t4, and then you make it equal to 27r cubed, because 4 minus 1 is 3. So then, you divide 8 by 27, so you get 8 over 27. and then that's equal to r cubed. And then you simply take the cube root of each side, and then you end up getting a number like 0.6666, which we know to be r because we just solved for it. So we can go back into our equations. So T2, we can go T2, and we can plug in r, or 0.66, repeat, to the power of 2 minus 1. And 2 minus 1 is just 1. So 27 times 0.666, repeat, to the power of 1 is equal to 18. So term 2 is equal to 18. So for T3, which we made equal to 27, r, 3 minus 1, 3 minus 1. So we plug in r, T3 equals 27 times 0.66, 3 minus, to the power of 3 minus 1. 3 minus 1 is 2, so it's just 0.66, repeat, to the power of 2 times 27. So finally, after doing that, you find out that T3 is equal to 12. So T3 is 12. And we don't need to do this for T4 or T3 because, or sorry, not T3, T1, because we already know that T4 is 8. T4 is 8. And T1 is 27, because that's the first term in our sequence. So back to the question. It asks, in the geometric sequence 27, x, y, and 8, what are x and y? Well, we found that T2, or x, so T2, is equal to 18. So that means that x is equal to 18. And we also found that T3 is equal to 12. So that means that y is equal to 12. So to answer the question, in the geometric sequence, the terms, the second and the third term, or x and y, are x equal to 18 and y equal to 12. Thanks.